Everyone, today we will study about the different radiation interaction with the tissues and the question mostly asked in NEET AIIMS MDS in recent years. Let's study about it. In interaction with the tissues, there is only 9% of the radiation which goes without any interaction with the tissue to the receptor film, and other of them interact in different way with the tissues. Let's study about it. You have to remember that only 9% without any interaction. Coherent shows 7% interaction with the tissues. Photoelectric absorption 27% and Compton scattering 57%. What are these three? Let's study about it. First, we will study about the photoelectric absorption, how it will interact with the tissue and how it will produce or how it will work. Let's study. When an incident photon from the X-ray tube reaches the human tissues, atoms in the human tissue have this structure. Incident photon when strike on this tissue in photoelectric absorption, it shows that incident photon interact with the inner orbital electron and transfer its whole energy to this electron, and this electron after interaction with this radiation gain its all energy and ejected out of atom. This photoelectron is ejected out and the whole energy of the photon is diminished or finished, and this whole photon energy is released in the form of kinetic energy of the electron, and some of the gain energy by the electron release from the orbital, giving to binding energy from the binding energy. So the kinetic energy of the photoelectron is equal to the incident photon energy minus में binding energy, and the kinetic it gains the kinetic energy and go out of the atom. This vacancy is void is created. This void is filled by the outer orbital electron. These electrons release some characteristic energy, which is the difference of their binding energy of the two orbit, and fill this vacancy. And this vacancy also filled by the outermost electron, which also release some energy and goes to the inner orbit. All the orbits are subsequently filled, completing the energy exchange, and the characteristic radiation is released, which is the difference in their binding energy. So in photoelectric absorption, the absorption of whole photon is occurred and only the ejection of electron is there. Bone which are of higher atomic number 13.8 and soft tissue is with the 7.4. Therefore the probability of photoelectric interaction of X-ray photon in the bone is 6.5 times greater hogi than the soft tissue. So this difference gives the diagnostic value of the radiograph contrast. So this difference in absorption of the photoelectric radiation or photon radiation by the tissues, this difference gives the radiographic diagnostic values. So we can see this as a different structure: enamel, dentine, pulp, because the absorption of these structures is different. Higher atomic number interaction is more than the soft tissues. So degree of radiopacity on the radiograph image we can see from these difference. In this type of interaction, the electron is also ejected out from the inner orbit. This electron will causes the ionization of the atoms. So this radiation causes ionization potential for biological damage. This photoelectric radiation accounts for only 27% interaction. You have to remember this. It can be asked in exams. Let's study about the Compton scattering. In Compton scattering, incident photon does not lose its whole energy like in the photoelectric interaction. In Compton scattering, incident photon only give a small amount of energy to the outer orbital electron, which is necessary, which is needed it for release from its binding energy and ejected from the atom, and gains some amount of kinetic energy. The remaining energy of uh, the photon is deflected from its pathway to some of the angle with the lower energy. So the remaining energy of the photon in this Compton scattering is minus binding energy of electron minus the kinetic energy of the electron. So in this, both photon deviated from the pathway and loses some kinetic energy, and also the and also the electron is also ejected out from the outer orbit. In Compton scattering, ejection of the electron and the photon both occur. In coherent, only the photon. In Compton, both electron and photon. In photoelectric absorption, only the electron is released. No interaction. That is the only 9% of these radiations which are passes through the patient without any interaction. Interaction photon from a diagnostic X-ray beam. Photoelectric absorption causes the ionization because the electron is released. Okay, there is those scatter photon. Practical implication is that the basis of radiographic image is formation. Compton scatter shows ionization because the electron is also ejected and the photon is also ejected, therefore shows the scatter also. Scatter radiation can degrade the image, expose personnel and the patient. Coherent scatter does not show ionization because no electron is ejected out. Only the same energy photon is released but at the different angles. No scatter, minimal contribution to the scatter. Let's study about some of the units. Exposure unit is traditional unit is Roentgens. Sometimes the question may ask in the Roentgen there is a exposure unit. The SI unit is the coulomb per kg, but the traditional unit is Roentgen. After the name with who discovers the X-ray, karma is the kinetic energy transferred to the charged particle and the unit is gray. Absorbed dose, that is total energy observed by a mass, is the gray, but the traditional unit is red. Some of the question may ask in the red, but you have to remember that if the options are given in the gray, the one gray is equal to the 100 red. Equivalent dose, that is the absorbed dose weighted by the biological effectiveness of the radiation type used, is the civet, and the traditional unit is gram. The one civet is equal to 100 gram. You have to remember this. Effective dose also, civet is the SI unit, and the radioactivity unit is the becquerel, and the traditional unit is the curie. So this is all about the radiation physics. Radiation interactions with the tissues. Only the 9% of the only the 9% of the radiations from the X-ray tube will goes without any interaction to the receptor film. And this is the detailed explanation of the three types of interactions, and this is all about the radiation physics. If you like the video, please like, subscribe and share. Thank you. In this Compton scattering, the scattered photon travel in all direction and may exit the patient and strike the image receptor, and also cause the fogging of the image receptor. This photon carry no useful information and degrade the image, reducing the contrast and causes the fogging also. Scattered photon that exit the patient expose कर सकता है operator को भी. And also the electron is also ejected from in this Compton scattering. So electron also just electron release also called the ionization of the tissue. The internal scatter increases patient's radiation dose and often expose organ and tissues outside of and distance from the path of primary beam. This Compton scattering accounts for largest interaction, that is 57%. You have to remember this 57% interaction is of Compton scattering type. Let's study about the coherent scattering. Lowest percent, only the 7% shows the 7%, only 7% shows the coherent scattering. Let's study about it. In coherent scattering, lower energy photons strike to the atom and momentarily excite the atom. When this atom stable and when this atom momentarily excited and quickly return to the ground state, emit some scattered photon of same energy, scatters same energy photon but at different angle from the initial position. You have to remember that only 7% of the scattering is shown is the type of coherent scattering, and same energy photon is released but no electron is ejected out. When X-ray beam from the X-ray tube, there are some low energy photons are also released. These low energy photons interact with the atom, causes the coherent scattering. Fate of photons. Coherent scattering scatter from the atom. Photoelectric absorption eject inner electron cases to exist, यानी फोटो इलेक्ट्रिक फोटोन जो होते हैं इन दिस एब्जॉर्प्शन मतलब कि एब्जॉर्प्शन हो जाती है पूरे के पूरे फोटोन की एनर्जी की, एंड द इनर ऑर्बिटल इलेक्ट्रॉन इजेक्टेड आउट हो जाता है उस पूरे फोटोन की सारी एनर्जी लेके, and characteristic radiation is released. In